Okay, good morning. Welcome to Austin, Texas for OARC 31. For those of you here for the first time, I'm Keith Mitchell, OARC President. I just want to run you through a few quick administrative things about the meeting, and then we'll get down to business. As you're probably aware, we're co-locating with the NANOG and ARIN meeting, so we're using the same network infrastructure. So you'll need user and password if you're trying to get onto the Wi-Fi. Also, if you need power for your devices, we have more power outlets down at the front here. They're underneath the tables, and fewer at the back. If you want to see some of the demonstrations that Jerry has put together, that's at the registration desk. They'll be rolling all day. The coffee breaks are in the foyer outside. Lunch is on the other side of the black partition there, so go out and back into the other half of Griffin Hall. Restrooms are down towards the elevators. If you have any dietary restrictions, we have plated meals for the lunch, so make sure that you request the appropriate food from the catering staff that meets your requirements. In the event of a fire alarm or the need to evacuate the building, there are emergency exits. I think you can go back down out through the main hotel lobby, and there's also exits on the opposite side of the elevator lobby. As usual, we'll be doing a PGP key signing. Matt Pouncett will be doing that tomorrow lunchtime. If you want to participate, then please send your key as an attachment to PGP sign at DNS-OARC.net, and please, if you can do that by 9 a.m. tomorrow morning. And Matt's put a tutorial together if you're unfamiliar with how to go about participating in that. We have 45 minutes of lightning talks tomorrow afternoon, the last part of the workshop before we start the member-only AGM. 5 to 10 minutes to talk, so we can usually manage 4 or 5 talks. Please upload the abstracts via the Indico app at that URL, and if you can do that before the break tomorrow. We have a social event. Yeah, it's a boat trip again, but this time we have bats. There's a bat watching cruise. It's at 6 p.m. sharp, so we do not have a huge amount of time between finishing proceedings today. So if everyone, if you could please pack up and if everyone could make sure they stick to their time today, that would really help. 15-minute walk from the hotel. It's going to be kind of cold than we expected, so make sure that you dress appropriately for either the weather or Halloween or both. It's paid for social. So if you haven't registered, please do that at the URL there. And if you could try and do that by lunchtime today, by noon today, that would just help us get the numbers right. There's still plenty of space there. And the back cruise gets back at 9:30 tonight. We're webcasting the event. It's on the OARC YouTube channel. So if you can avoid extraneous noises during proceedings, that's helpful. For questions, we have a single microphone here. So please line up if you have a question and identify yourself and your affiliation for the benefit of the people in the webcast before asking your question. And remote participation back channel is via our Jabber room, and there'll be the usual activity on the various social media channels. I believe we have most of our slides uploaded, but if you haven't managed to do that, or if you have any issues or special AV requirements that you haven't already made us aware of, then please see myself or Shumon. Usually we have a reasonable amount of time at OARC workshops, so if you can try and speakers, please keep to your slots. That would be really helpful. Also, we're trying some new clicker technology, speakers, this is the thing to use for advancing and taking back your slides. Hopefully it will be less vulnerable to RF interference than what we've used before. And also the timekeeping hints that you get from the timekeeper as a speaker, that is to the end of you speaking. There's still about 5 to 10 minutes at the end of your slot for Q&A, which isn't included in the timekeeping countdown. And obviously when you're on the stage here, try not to emit any extraneous EM radiation. And the other thing is, thank you to all the speakers. The speakers all come here on their own time and expense. We would not have a workshop without their participation, so thank you, speakers. Also, just a final reminder, we want everyone who is here to have a welcoming and good experience. We have a conduct policy. You all agreed to that policy when you agreed either to sign up as an OARC member or to attend the workshop, so please make sure you're familiar with that. if you need help with anything, staff, board, PC, we all have black lanyards. Those of you with red lanyards, they're your first timers, so welcome. I hope that all our old-timer usual suspects will take the time to make you welcome as well. Okay, we'll now move on to the workshop content proper, and I'll give you a few opening remarks from the OARC chair, Dwayne Wessels.
Yeah, hi everyone. I'm Dwayne. As Keith said, I'm the chair of the board of DNS-OARC. Just want to repeat the welcome and thank you for coming. As someone who's been involved with OARC for many years, it makes me very happy to see what this has grown into, and that's really due to you as people willing to come and speak and come and listen and volunteer for all the things that we have that you can volunteer for, the board and the program committee, and we have a bunch of volunteers here keeping things running this morning, so thank you very much to them. And thank you also for giving up your Halloween to be here. Happy Halloween if that's a holiday that you celebrate. So we know the timing's not the best, but we very much appreciate you coming here. That's about all I wanted to say, so let's have a good conference and see you over the next couple days.
Okay, thank you, Dwayne. Okay, so before we get down to the actual technical meat of the conference, I just wanted, specifically for the benefit of those of you who are here for the first time, to say a little bit about OARC and just to give you some idea of what we do and who we are. What is our mission? We want to make the DNS work better, and some of that we do through coordination, but it's also about research, measurement, providing tools and services that allow you to measure and debug and understand the DNS better, and then to use to use that knowledge which is gained by the process of data gathering and analysis and cooperation to share that. And we do that through our workshops, and we do it through various other activities that we engage in, and also just try and do some public outreach there as well. We have a very diverse community of members. You'll see them some very large names there, right down to some of the smallest CCTLDs in the country. We have a lot of support from vendors, both commercial and especially open source, GTLD operators, registries, registrars. We have nearly 80 members and then nearly 30 supporters who provide a very diverse and supportive community. It's kind of hard to explain what we do in terms of, you can say things about operational coordination, analysis, research, but if you're not a technical person and you're trying to explain to your mother what it is that you're doing, I mean, we're, in terms of analogies, we're kind of like a library because we have this huge data set, but we're also kind of like a learned society because we don't just let it sit on the shelves and have some people read it and check the books out. There's much more interaction and knowledge sharing. I mean, one way of summarizing it is where DNS experts work together. But I think that the best way to understand what OARC does is to get involved and to engage with the other members, come along and share what you're doing, what you've learned, once you've done that, then it becomes a lot more obvious why we're here. We have a bunch of technical resources that facilitate this. The biggest part of that is a data set, 300 terabytes of data going back, gathered live from the DNS, over 15 years now. It's not a complete view of the DNS over that time, but we certainly have some pretty interesting slices of it. Most of our infrastructure is in Fremont, California. We have analysis servers that members can use to inspect the data set there. Another increasingly important part of what we do is open source DNS tool software. Some of that we have developed over the years. Some of it is very recently developed. And the other thing that we've been doing quite a lot of is inheriting tool sets that were originally developed elsewhere, have maybe fallen into lack of maintenance or support. We're very much taking that on board, and we're also getting good funding to support us doing that. The tools aren't just there for you to use. We also run a bunch of tools and services ourselves to perform testing and debugging, monitoring. And we also have a couple of other sites where we provide some redundancy on our technical infrastructure. How do you support OARC? Becoming a member. If you're not already a member, please strongly ask you to consider doing so. There's a sliding scale. There are a couple of entry-level categories for small or academic organizations. But in general, we hope that corporations will step up and support us with a funding level that's appropriate to their resources. And some of our members support us very well indeed. Governance, it's the boring vegetables as opposed to the technical meat, but we think it's important that we have our own legal entity. I mentioned that we have a diverse member base. We're financially self-supporting, which doesn't necessarily mean that we live in luxury. We're a non-profit, but over the past few years we have managed to make sure that our about $800,000 a year of revenue expenses are close to each other. We have self-governance structure. We have a declared neutrality policy so that we're not acting in the vested interests of any one party. The board is elected. Members will get to elect new members to the board at our AGM tomorrow afternoon. We have a bunch of staff like myself who are contracted to provide the services. We have an awesome program committee of volunteers who every year put together the kind of full program that you've seen. And we're a US legal entity and a formal federal and state non-profit status. These are our board members. All of them except George are here, so do feel free to speak to them, especially the ones that are up for re-election. I'm sure they'll be happy to tell you more about OARC. Staff, again, we're all here except for Pam. We provide a number of roles. One of us works full-time, most of us work part-time on OARC and potentially some similar related activities. Program committee, again, most of the program committee is here and they've done a huge amount of work. We'll be looking for volunteers for next year's program committee and some of the existing program committee I hope will continue to serve, and then it's nice to refresh that a bit as well. The workshops, we've been running 2 workshops a year. Next year we're going to 1 extra half workshop. That gives us a bit more stability in terms of co-locating with NANOG this time. We co-located with ICANN in Bangkok earlier in the year. We'll be co-locating with RIPE next year. The co-location, everyone says, well, why are you in such a fancy venue? We're in a fancy venue because the co-location with the larger events makes life a lot easier for our attendees. And there's also a lot of overlap and synergy. You may be aware that the ARINT meeting is also on at the moment. That's one floor upstairs. We try not to overlap, but we had a logistic challenge this year. If some of you are switching between here and ARINT, then I hope that works out okay. But the workshops survive on sponsors and patronage. I'd like to thank Comcast as our main sponsor for this workshop, and VeriSign as our patron who sponsors us throughout the year for workshops. We'd love to have more sponsors and patrons, so please talk to Dinesh if you're interested in doing that. What do we provide? We provide knowledge sharing, we provide tools, we provide a bunch of online platforms and services, we provide the data set, we provide the venue, both in terms of physical workshops and various online spaces for operators and research. You can think workshops are one of the things that we do. You could think of us as a kind of global DNS-OARC, but it's by no means the only thing that we do. Next workshops, we'll be co-locating with NANOG again in February. That will be in San Francisco the Saturday before NANOG. On the Sunday, we have a number of other activities planned which will attach to the workshop. And then in May next year, we'll be doing Paris in the springtime. First time we've been to France, and that will be immediately after the ICANN IDS symposium at GDD, and immediately before the RIPE meeting in Berlin. Again, I mentioned the conduct policy already. So if you're not a member, why should you become a member? Because it lets you become a participant in this unique technical community and to learn from the unique experts that we have here. It means that the tools and services that we're developing, you have a chance to tell us what it is that you want and to help resource the development of these tools in the direction that's useful to your business. We have the data set, which really can give you insight into the DNS on a global scale, unlike anything else. We're not a cybersecurity organization, but we're certainly here to help facilitate issues, incidents, and threats to the DNS global infrastructure and help deal with these. And another important part is we're neutral. We're not tracking any one particular vested interest or commercial agenda. And really the best guide I can give you is why is OARC worthwhile is some of the testimonials, some of the really nice things that some of you already said to me this morning. People who come here appreciate it. If you've not been here before, please talk to the other attendees and they'll give you an insight into what the value of OARC is. Finally, you didn't come here to hear me talking about governance and what a great organization. You came here to do stuff that makes a difference to your engineering. So please, Jerry is running the demo booth outside, which is showing some of the software and services that we have. Please have a look. Jerry will be more than happy to tell you about these. I'm happy to take any questions now, but really I'd like to hand over to the program committee chair, Shumon, and Shumon will introduce this morning's technical content for you.
Thank you, Keith. So I'm Shumon Huck, and I'm with the OARC 31 Program Committee, and I will be introducing the speakers for the first session this morning. So this session includes a set of talks on DNS operations. And first up, we have Manu Brachel from Facebook, who will talk about a new name server that they built. So come on up, Manu.
Thanks. Good morning, everybody. About a year and a half ago, I was actually standing here, talking about our DNS infrastructure at Facebook. At the same time, we were actually deploying a new name server, but we were actually developing it at that time. So today, I'm going to go through the process that went through the development and the deployment of that name server. Okay, so this is meant to work better. Okay. Can I go to the next slide? Is it the green button, I guess? Yeah, it is. All right. So, anyway, my name is Manu. I work at Facebook. I'm a production engineer there. I work on the traffic team. And among other things, we do take care of DNS. We've been using TinyDNS for a while, since 2012. And it has worked for us pretty well. TinyDNS is simple, and it runs pretty efficiently. Let's give it a try. No?
Sorry, it's just not moving the screen.
I'm going to wait for the slide a bit. Or if you can go to the next slide, maybe.
Yeah. Sorry, you might have to advance it forward.
I'm going to give it a try again. Right, so yeah, a bit of history about DNS at Facebook. Next slide, please. So we've been running TinyDNS for a while. TinyDNS last update was from 2001. So we had to add a few features like IPv6 support. TinyDNS also comes with some location. So basically you can assign a given subnet to a given location. And, but this was limited to at the octet level. So we added a few more features like being able to provide CIDR-based location. And also eventually about 2-3 years ago, we added support for ECS. We also needed to have multiple maps, so we can define different location based on the names you're looking for. Next, please. In terms of features, there's not much we need from a DNS server. We use DNS to be able to, answer DNS requests, but be able to steer traffic too. So essentially, we really need to have this kind of resolver-based views and ECS-based views. Next, please. Can we go to the next one? Sorry? No. Thanks. So yeah, operationally though, it's a different story. Over the years, we've built a pretty big pipeline of different components. We have humans making change on one side. We have robots or automation that do other changes. And we have a whole pipeline which is built up that generates our final data zones and distribute that to our servers. And essentially, we want something that is made of simple components. Everything has to be simple to configure. We need to take away the complexity from the human, and we need some other things like query logins, so you can do troubleshooting, service health metrics, so you can understand how your fleet works, and essentially we need to be able to integrate our servers in our infrastructure because as much as running a server is one thing, we need to be able to operate it. Next, please. So TinyDNS was great. It worked well for that. It was simple, efficient. It was very opinionated. You have one way to start TinyDNS. There is not 10,000 flags or whatever. The line-based format was also very convenient. It may be hard to read sometime, but actually it's very convenient for machines to generate, and it's also very convenient for humans to use greps and OARC and stuff like that to be able to do some troubleshooting. TinyDNS generates basically TinyDNS data will generate a data file, a data.cdb file that we ship then to the servers, put in place, and the DNS server will pick it up and be able to start answering requests. Next, please. But why do we want to move away from TinyDNS? Well, as much as it's simple, it comes with trade-off. It's really hard to evolve the software. There is a lot of global and static variables. As much as it's rock solid, it's not really what developers nowadays are the most used to read, and it was very hard for engineers to be able to get a grasp of what change they could do and how it will impact the system. Next, please. So searching for alternatives. Next, please. If you look at the open source ecosystem, there is the usual contenders, Bind, Not, NSD, and PowerDNS. Back in January 2018, when we looked for a new solution, not everything was supporting the resolver or the ECS-based views. Bind had support for resolver-based views through the views, but it gets really cumbersome if you start having a lot of different views. Not had no support until 2.7.0 that was released in August 2018. NSD had, and still has, as much as I know, no support for views. PowerDNS actually had support for views and ECS or using the GeoIP backend. At the time, I missed that, but regardless, next please. Even though we had found a solution, we still have this operation thing that goes on and that generates a lot of content. And if we move to another name server, and then also we may have to change all this part. And we invested a lot of time there. We spent a lot of time to improve it, to make sure that we have failed safeguards, that we're not going to, that we can introduce changes safely without potentially deploying a bad database. Deploying a database file also works really well for us. We've been using BitTorrent for that, and it has been serving us pretty well for a lot of time. Next, please. So what then? Thank you. Essentially, what we're looking for is some kind of plugin, right? We want to have a server that basically receives a request and does the magic of unparsing the DNS packet and ask us, hey, what will you answer for this queue name, queue type? And then we give it the answer back, and then it will take care of funneling this back to a client. And if you look at name servers that do support some sort of plugins in one way, they have different naming for them. But here there is a new contender that comes around. It's called DNS, which is just basically a name server which is made of plugins. Everything is a plugin in there. Node.dns has support for modules. PowerDNS has support for backends. Next, please. So do you roll dice and see what comes out? Like do a modulo 3 and whichever number in your, you pick it up from the list? Well, not really. There is a few things you want to take into account when you're going to start picking up solution. I mean, you want to get something that, you want to get a sense if this is going to work out for you or not. So you want to find something which is pretty easy to get started with. How much time do you have to learn either the library or the software stack to be able to get started? How easy is it going to be able to build that and do run test? So that's to get, can you go back please for a second? So that's to get started. But then eventually, if you move with that solution, like people will have to support that. How familiar are your engineers with the language or the library used? And also, then eventually we'll have to potentially deploy that to production, right? So how can you easily integrate that into your production system, into your build tool chain and your packaging tool chain and all your deployments? Next, please. So Core DNS came out as a solution here. The plugin tutorial is excellent. You really get started in like a matter of maybe half an hour. We already had experience with the MIG DNS Golang library, so that was a plus. Like people, part of our DNS pipeline was actually had been rewritten in Go. It was actually, it's also very simple to use. It does abstract away the core DNS concept, and you kind of get these DNS object structure that you can easily manipulate and do stuff with. And the Go tooling is actually very great. I mean, if you have Go installed, you just go get core DNS, and then you can start building, running, and testing the server. Next, please. So there we started, and we started the development of the server. There were going to be 4 phases, roughly. Start with a proof of concept and see that you get something working. And then, if you're satisfied from there, then, move on to the next step, like actually try to be able to provide the answers you will expect from your name server. And as you move on, then you will want to integrate that into your infrastructure to be able to build it, deploy it to production. And if you want to hit production, then you need to be able to have the right monitoring and query logging and be able to make sure that you have the right performance characteristics. Next, please. So the proof of concept time. This took about 3 weeks' time. The core DNS plugin tutorials took about half an hour, but to be able to read from our database and stuff, we needed to start to do a bit of grunt work here, like be able to read from CDB, be able to do some of the basic bookkeeping we need to do when we receive a request, like finding a map which is assigned to a given query, and for that given resolver or ECS, find the location that we should use, and then find the actual DNS data that we will need to return back. And here it was definitely worse. Like there were a lot of investment in unit testing, and that really paid off a lot. So as much as it will slow you down slightly at the very beginning, eventually it's a phase where there's a lot of change, and you start going one direction, and then you may be ripping it off and then going another one. And as you make changes, you want to make sure that whatever you built before is still working. And there were definitely no rules in terms of hacking. Like if you need to get something that, you need to get it working, and you don't want to spend 1 week to try to get the dependency working the right way. You just want it to get moving. And eventually after that, there was something that could work, that did answer some requests, not all of them. Performance was not great, but it was a good sign that it was worth moving on. Next, please. Next, please. Then maybe the old slides. Right, so the next phase was the compatibility phase. I guess there is 2 ways to create a new name server. One is to do it by the book and follow all the IFCs, and we know how many there is. Well, we don't really know because there's too many, I guess, but that's going to be a lot of reading and to be able to make sure that your server worked. On the other hand, we already had TinyDNS that had been running in production for years, and we know that whatever we replied there was actually working. So as a starting point, the goal was to just mimic whatever we were returning with TinyDNS and be able to have a mirror of the service. And from there, we could take it into moving into different steps. So in order to be able to make sure we were actually doing the same thing than TinyDNS, aside from being able to have access to the source code and reproduce the logic, in order to validate that what we actually do is what we thought, we could create a validation script that will take query that we receive, that we get from our query logs, replay them against TinyDNS and against the FBDNS, the name server we were building, and compare the result. And if there were any discrepancy, then we will basically fail and log, oh, we failed this query, and this is the difference between the two packets, and find the bug, fix it, add unit test, rinse and repeat. Essentially, at the end of this stage, of this phase, we should be able to put the server in production, and it should answer the right thing. Next, please. So now that we were able to answer the right answers, then came the integration phase. This was 2 weeks' time, and here, essentially, we got rid of the core DNS dependencies. The main reason is core DNS comes with a fair amount of plugins that provide, useful functions, but we don't use them, so we don't need them. And there were no need for us to pull all this extra stuff when we were not going to use them. So there, we built a standalone UDP TCP listening layers that will basically receive the DNS request, and then we will chuck that into the served DNS entry point that core DNS use, which we had created before. We also did a few things here, there were a lot of helpers provided by core DNS, and we did copy them over rather than properly managing the dependencies. It helped us, moving a bit faster than just spending more time trying to sort everything out properly. And finally, now we could build that package and we could deploy it to production if we wanted to, but we wanted to know how it how it looks in production. So there were actually quite a fair amount of time here. I mean, the time frame I mentioned obviously is not coding all the time on this, but there is a lot of things that happen during the day at work. But around a 1 month's time frame anyway, we added query login metrics. We did a fair amount of refactoring of the code. And also the fun part, which is profiling, running DNSPerf against the server, finding how it compares in terms of QPS to TinyDNS, find the hotspot, optimize that part of the code, and basically move on to the next hotspot. And eventually, after a few iterations like that, you find a few places where you can get a lot of performance wins. And we eventually got to the same performance than what we got with TinyDNS. So then, next please, came the deployment phase. The strategy was going to be simple. We have A and B name servers. We will be using A as our control/stable group. And if we messed up so bad with B, at least part of the infrastructure could answer the right thing. We will be starting small, pushing early in the week because sometimes issues don't manifest in the next coming hour or whatever, and you don't want to push on a Thursday and be working on a Saturday to fix it. And as you push more and more to production, then you build the confidence that it does work and you deploy more and eventually everywhere. Next, please. So starting small. You take the binary, you start running it in production. Type of canary, make sure nothing obvious crashes or whatever, and then eventually you push to a full cluster to be able to compare week over week how the performance is doing. You leave it there for some time to make sure that there is no hidden issues that just come up with after running for some time. You make sure that the traffic pattern don't obviously change and that the performance seems to be fine. Next, please. And the outcome was actually pretty good. We had a 60% CPU usage reduction and a 90% memory reduction too. It's kind of strange because TinyDNS is simple, as I said before, and it doesn't use that many resources. But we were not really using TinyDNS on its own. We were actually using TinyDNS, which was piping the logs into a wrapper that will receive those logs, parse them, make sense out of them, format them in a way that could be sent to our logging pipeline and also compute statistics. And this part of the pipeline was actually taking a share amount of memory and CPU. Anyway, everything was good, everything looked great, right? So we could move on. Next, please. So 7 days later, one more cluster, leave it there for some time, see what happened, traffic is not changing, everything seems to be good. So then you gain more confidence, and then next, please. Then you start rushing a bit more, you don't go one cluster at a time, and you start pushing a few more clusters. And this is when things started to get a bit wrong. We did a push around noon, and later during the day, actually, starting from the time of the push, as the binary get to more and more machine, people started to report in some internal groups that they were seeing some weird DNS issues, and eventually, around the end of the day, it came to my team. I mean, knee-jerk reaction, you just quickly revert back to TinyDNS. I mean, you have an obvious possible problem here. You're deploying a new software. So we reverted back to TinyDNS, everybody was happy, and then we could take the time to troubleshoot what happened. Next, please. So I had run those validation tests prior, but it turns out that spoofing a source IP is easy, but if you want to get the answer, it becomes a bit more tricky. It's not impossible to do, but it takes a bit more work. So the validation tests we've been doing were actually leveraging ECS to be able to exercise the different location and making sure we will be getting like the same answers. But we had missed one part. The one part was, next please, that even though we were using unit test pretty much everywhere in the stack, there were like 5 or 6 lines before calling the function that was meant to find the location that were not tested. When we receive a request from a resolver, we get an IP address. We need to convert that to a network. There were a silly mistake that happened here that went unnoticed during the whole phase. And basically, we were just like not returning the right location for the given subnet. That only happened for traffic coming from IPv6 resolvers without ECS. The issue was pretty easy to understand, to reproduce through unit test, to fix, and then we can move on again. Thanks. Next, please. So eventually, we quickly moved on to where we were. We had fixed the issue, so we could easily deploy back to where we were. And there, nothing broke anymore. Nobody reported any issue. And over the next 2 weeks, we deployed to 100% of the B name servers. We let the A name servers for 5 more months running on TinyDNS. There was no big rush here to push more. The 5 months was, there is no science behind that number. It was just long enough that we were confident that we were fine running that everywhere. And then after 5 months, we basically pushed to the rest of the A name servers over 2 weeks. And you will think, you're done, right? You've been running in production for 6 months at least. You think, everything seems to be good. Next, please. But actually, 1 year later, you start paying the tech devs that you collected and didn't get back to. It was a funny issue. The timeline is actually pretty funny. In the part where we removed the dependency from core DNS and we copied some of the file to go a bit faster and not deal with dependency management, we had copied a version of the request.go file on the 2nd of March 2018. On the 21st of March 2018, there were a bug report on core DNS saying that there were high CPU load. We only found that out later as we fixed the issue. The 22nd, core DNS had a fix for it, and essentially if we had picked up that file on the 23rd, we would have been gold. A year later, we needed to update that file because there were new helper functions that were useful and a bit more caching. So Genuine, which is here in the room, actually made a diff to pull this in. And on the first 2 days later, like on the 1st of May, we had an actual internal incident where some of the FBDNS tasks were busy spinning one full CPU. And through troubleshooting, we could actually find what was the cause. We could mitigate it. Somebody found that there were these bug reports and that it had been patched and stuff upstream. And the funny part here is really like, this was caused by somebody changing, it was triggered by somebody making a configuration change that triggered the bug. Had that person made that change 1 week later, we would have never known about it because the change from the diff from the 30th of April will have deployed into production over the next week, and we'll have never known that we had been running that for 1 year. Next, please. So I guess the lesson here is tech devs are fine. I think you really need to find good compromises and be able to take some in order to move fast than just getting stuck. But you should really get back to them. Get rid of the copy paste is going to be a bad idea one day. Try to use proper dependency management and avoid forks as much as you can. Work with upstream, find a compromise of where everybody gets happy. Like you have a change that helps you, also helps others. And yeah, keep your third party up to date. Make sure that you have regression detection, because if you keep up to date, then you may introduce changes that will break your software. So make sure that you can actually detect that. Invest in continuous stage rollouts, because that helps you gaining the confidence of building a new binary. and deploying it. And fuzzing is actually doing a great work at finding these kind of weird edge cases that you will never think of using unit test. Next, please. And I guess finally, I'd like to thank a bunch of tools and software out there. So I guess DNS and Core DNS, I mean, we've been leveraging the library for a while. The Core DNS software has been a good inspiration of how to build our own DNS server in the end. The rest of the open source DNS software, because they're also very good inspiration on how to solve a problem or how to make sense of how we could approach, a solution versus another one. The DNS compliance testing framework has been really helpful to make sure that we were passing the DNS flag sniff test. And finally, DNS-perf also has been a great help because anytime you will be making change, it's a very great way to be able to test performance and send a bit of data to your local test. Thank you. I think we have time for questions.
Okay, are there any questions for Manu?
Hello, this is Martin from SIDN. One quick question. Is this also available as open source?
It is not. It will need some work. There is no reason it should not be done. It's a matter of time. Be able to decouple things that, where we took a few shortcuts to be able to run that in our infrastructure.
Okay.
But I have a hope that one day we do it. It's a matter of time, resources.
Yeah, that would be nice. And one other thing, does it support DNSSEC?
It doesn't.
Okay, thank you.
Any other questions? So we still have a little bit of time, so I'm going to slip in another question. I was going to ask about DNSSEC too, but I think I'm
getting used to that question.
But how about DNS privacy? Do you have anything to say about?
Well, I guess yeah, that has allowed us to implement DNS over TLS with Cloudflare. Thanks for bringing that up. Yeah, so I mean, supporting TCP became very easy compared to with TinyDNS. And then we could easily plug TLS support. So we've been running that with Cloudflare, I guess, for a bit more than a year now. And we had a post about our experiment. Yeah.
So I did read where you were doing the trial with Cloudflare, but is it
Still
generally
running.
open now to anyone?
It's still running. And I mean, if anybody wants to talk to us over TLS, I would be here for the 2 days. And hit me up. And I think also my email could be found through the DNS-OARC portal, so I will make sure you can. And so send me an email otherwise. Thank you.
Okay, great. Thank you very much, Manu.
Thanks.
Yeah, I'll introduce you. Okay, so our next speaker will be Davy Song, who's going to talk about the Alibaba Cloud DNS service. So I think, Davy, you've attended OARC before, but this is your first time as a speaker, am I correct? Yeah. Okay, so let's give a warm welcome to Davy. I think you'll have to ask to advance the slides. Okay. It's not work here? Is it working yet? Or? It works. You'll see the green button. It'll, okay. So that's the link.
Not work very well. Okay, please, from the first page, okay. Morning. I'm David from the Alibaba DNS team. I just joined this team 4 months ago, and it's my pleasure and honor to present this team's work and the product as an overview. Firstly, I would like to give you expectation that it's not comprehensive and not a deep dive into some particular technology. It's just, I want to share with you from my personal angle in the past 4 months. And I want to go through with you, just like myself, to know what the people in Alibaba approach DNS and what they do DNS and what the challenges are. Okay. And I also would like to share some of my thoughts. Okay, please, next slide. Okay, this slide go with 3 parts. First one, I would like to introduce, because the first time to introduce Alibaba and our team here, so I would like to introduce some background of Alibaba and China a little bit. And the second part is about the introduction of the team and the product we made. And the last part is some thoughts and hopes why we joined OARC here. Okay. Firstly, I would like to introduce to you some pictures. It happens 20 years ago that there is a public test question on how you can survive with only computer and internet in 1999. And at that time, not many people have no idea what internet is and what capable of it. So there is a kind of top public test and competition on that. 1999 is a special year that in the eve of the internet bombing in China, and also it's the year Alibaba was founded, doing its first B2B business online. In 1999, I was just a high school student. I'm lucky that I have my own computer and play games with people around the internet, so that I can I'm very confident that I can survive the test for the 3 days with water. Is okay for me. Next slide. Okay, another picture is that the one example that in the past 20 years, there's huge change. That's one example that the internet build trust among people on the mobile payment among the people, adults and youngsters who not even use credit card and checks. Okay, next slide. Okay, this slide I would like to give you some numbers to describe right now, what's the situation, the China's digital economy. That's the environment, how Alibaba grows. So I don't read the numbers for you, but I just want to say Alibaba is one of the largest internet companies that support and contribute more than half of China's digital economy. And on one hand, the internet technology enables the large internet companies in China, like Alibaba. But on the other hand, large internet company in China, I think it's common that it's make it very difficult for the company to adapt to the changes. It left behind many issues, like the security and privacy issues, and also some of the issues like supporting IPv6, supporting DNS-OARC, because in the early phase, most of the internet companies are running for the market share, and they are not, to catch up the pace of the technology itself to comply to the standards. Okay, so I just want to say in most cases, people, in the internet company like Alibaba, we are fixing engines when we're driving a very fast jet. And it makes it very difficult to how to adapt to the changes, or to how to add new features or change dramatically of the infrastructures with some history reasons. Okay, and also the jet is not carrying one person or one team of a company, but the home ecosystem, home economy, just built on the infrastructure. It will be a disaster if the infrastructure is not stable. Okay, next slide. Okay, I would like to take some time to give you a brief introduction of how Alibaba looks like and what business Alibaba does. If you are very familiar with that, it's maybe the perfect time for the bathroom. Alibaba starts from a mission to make it easy to do business anywhere. The core of the business is the sellers and the buyers. What we do is to facilitate, to help seller to sell product and services to buyers, and help buyers to find the best product online for buyers. We build large platforms to achieve this goal, and they use some core three groups of services. One is the core commerce. The Taobao and Tmall are famous one of them, and also the mobile media and entertainment apps and applications. And they also provide a group called local services, so that you can order services. You can order takeaways just at your home with your mobile phone. And to support those services, there are several layers as the infrastructure. One is about the payment, so the Ant Financial supports the online payment, and they build the credit system to do some financial business. There is also another infrastructure called Cainiao network, do logistic business, to help people to get what they buy as soon as possible. And there are also a layer infrastructure as Alibaba do the marketing services. And the bottom line, I just want to say the bottom line is the AliCloud, that we built all the ecosystem on one single infrastructure. And we also share the ability to host other companies' business on the Alibaba Cloud. And DNS team, Alibaba DNS team belongs to Alibaba Cloud, belongs to the network department as one of the function of the Alibaba Cloud and networking department. Okay, that's the position of Alibaba Cloud DNS team. Okay, I think, yeah, okay, I want to emphasize another point is that like most cloud infrastructure, the goal of DNS is to provide a stable and a secure foundation for all the platforms in Alibaba ecosystem. And there is a number I want to share with you that there is a festival called Double 11 on November 11 that is coming soon in this month, and people do online shopping just like people do shopping Black Friday in the United States. And we achieved, last year, Double 11 Festival, we achieved 10 billion GVM in RMB in first 2 minutes. And we have up to nearly 500,000 transactions per second. So that's the size of the transactions and traffics happened in this platform. So it's joking to say that the goal of our infrastructure is to just get rid of us, make ourselves invisible, because it's if you are famous, there's something happened, wrong happened. So no news is good news for us. Okay, next slide. Okay, This part I would like to give an introduction of what we do and what challenges we have in this part. Next slide. Okay. Alibaba Cloud DNS is highly available and scalable domain name system that provides authoritative DNS and management services. You can just refer it to as a managed system, a managed DNS, authoritative DNS. And we not only provide managed DNS, but we also has the responsibility for the all production network of Alibaba ecosystem. So the services we delivered is only part of our responsibility. And for one hand, the Alibaba Cloud DNS provides stable, safe, and fast connections between end users' devices to the internet resource, mostly in the cloud. And also, on the other hand, you know, the traffic now concentrates on the big players, big companies in their IDC, in their network. So the Alibaba DNS, Cloud DNS also need to support the traffic and the connections in cloud, mostly localized cloud. Sometimes it supports the traffic between regions, between available zones, and also need to support some mixture of networks between private zones, private cloud, and the VPC in the cloud. Okay. And I also would like to let you know some challenges we are facing. When I ask my colleagues, what's the big difference between, the normal DNS providers and Alibaba Cloud DNS? The answer is that most of the DNS providers provides make client that they have high performance in terms of QPS, both the DNS query QPS and the API provided for the customer to change their DNS record. And also the availability, and I think many DNS provider provides SLA to their customers, and also needs accurate traffic scheduling and load balance. I think that's the common properties that are required for the DNS provider. The challenges in Alibaba, we are facing the challenge is that we need to keep the property in very large network and system of huge size and scale. That's the challenges we are facing. How large of the system? I can give you some numbers. We have, some apps are national, we call it national apps that millions of people use it, like the Alipay and Taobao app, and we have 116 million query per day, not mention the peak traffic during some festivals. And we have a lot of data centers and globally. Next slide, I will show you how many regions and available zones. And we need to manage millions of virtual machines and many VPC, virtual private zones in the cloud. It's really a challenge to manage all this resource, all this service with a domain. We usually identify the domain and the service instance use DNS names. It helps to management, give a efficient management. And under that side, that large network system, we still need to keep high performance. Especially, we need to provide 1,000 records change per second and faster propagation time in seconds. It's really a challenge for us. And we need to keep high availability and provide a failover in less than 5 seconds, I think. And we also need accurate traffic scheduling. and load balance between those facilities. Yeah, we enable abundant policy to schedule this traffic. Okay, next slide. What do we do DNS in cloud? Usually, DNS protocol and the function is the mapping, provide a mapping from name or identifier to IP services or resources. So we do the same thing. But we use the DNS to do the domain name resolution, just as I said that many servers in IDCs and cloud service instance. We have our self-developed software with high performance to achieve high performance domain resolution. And we enable the network connections both inside and outside the cloud. We provide private zone and customize the DNS technology to connect different VPCs. We enable the traffic scheduling based on different weight, different regions, and available zones, because we have abundant China ISP lines and world lines. We enable the fast failover and recovery based on Alibaba Cloud monitoring platform. And also we have a high redundancy to support a fast failover and recovery. Next slide. That's the product and the services introduction. We have 4 generally. One is the domain name resolution, just as our authoritative server does. And private zone, it's an inner DNS for VPC. And we provide a GTM to globally schedule the traffic for failover and recovery. And we also has, we call it Apsara Stack DNS. It's DNS for private cloud. Now the Alibaba DNS is the largest DNS provider in Asia. Next slide. This picture shows that Alibaba Cloud DNS fully use the facilities and the infrastructure of Alibaba Cloud. Globally, we have 20 regions and 57 available zones. Most of the resources are located in the Asia part. Next slide. Okay, I think I can jump this part because it looks like an advertisement. Okay, I give a link. I give a link here, and you can tick it and got what benefit, which features we provided, so that we can jump to back to next slide, and next slide. Okay. I want to introduce this slide because it's not a sexy page, because as I said, that in the early phase, Alibaba is not follow or catch the pace of the community very closely. So we just customer-driven, requirement-driven business company. So, but I think I would like to introduce this page because I view it as a commitment and openly to catch up the pace of this home community. So there is some time and date. We support IPv6, and both for authoritative server and public DNS. It's very late, right? And DNSSEC will be to be online in the end of this year. And we are proud to be the supporter of DNS Flag Day because some of our customers ask us to support this because I think they influenced by some initiative like the DNS Flag Day and some meetings. I think advocacy is very important to support, to push the industry forward, to influence the customer. They may have the idea why DNS should support TCP. Okay, and we also would like to cooperate with some root server operator to provide localized root services. The consideration is the data privacy, failover, and network autonomy, some kind of network autonomy. And we evaluate the different approach, and we choose to introduce more root instance from root operators to facilitate the region's network. Okay, next slide. Okay, there are three cases I would like to share with you to add some technical stuff here. Very simple case to use DNS weighted record for load balance. We can weigh different address, A record or quarter A record, so that the traffic we can split accordingly to the servers. So it's very simple, but it's not a standards. It's just a trick to support this part. As far as I know, in the data center, we use more advanced technology to share the load balance more promptly between the containers. They use some client, they use dynamic DNS technology, but they have a client side in each container, so they can push in advance or prefetch the service to load balance the traffic among the resources. Next slide. The second case is that DNS for VPC and isolated network. The challenge is to provide private DNS resolution for each VPC in a scalable, stable, and efficient approach. Usually speaking, there are two approaches, two models: distributed model or centralized model. You can set up a distributed DNS servers for each VPC, or you can centralize the DNS facility and to distinguish from different virtual private zone, private network. So in Alibaba, we provide a private zone in a single common DNS so that we can enhance the efficiency and yeah, it's a choice, right? Okay, now the next slide. The third case, I would like to say that 6 years ago, Alibaba already, the people in Alibaba already do the application DNS. Just as we say today, ADD. They use the HTTP DNS to do the DNS resolution on the application level. The goal is simple, that to avoid the interference from the third-party network and DNS, like hijack, have more control of the home resolution loops. And they provide HTTP DNS SDK for app developers to enable the apps to do the DNS in application level. And they can achieve accurate location, geo-scheduling, and avoid domain hijacking, to avoid the impact of bad TTL misbehavior. And they can also do some great gated launch for the new application. Recently, as far as I know, the group who do the application DNS is to introduce some software-defined DNS, use Alibaba function compute to enable domain names to hack in the logic, in the resolution process, so that they can respond more promptly and with more end users information, so that it helps in some scenarios like the faster failing over and load balance scenarios. For more information, you can, I need to provide some link for reference, right? Yeah, you can maybe later. Next slide. Yeah, okay. The time is okay. I would like to share some thoughts and hopes. And when I entered the Alibaba team, and they had just finished, Alibaba and the DNS team become #1 in Asia for years. So we decided to move another step, because long time we are beneficiary of the technology and the community. So we would like to embrace more. Firstly, we want to increase the presence, and we want more communication, so that we can help when we have more feedback to the community, so that we can to identify some challenges together and leverage the platform to share some thoughts. Next slide. There's some thoughts not for the home team, but for myself. I observed that there are two driving forces to the DNS technology. One is the the evolution of the infrastructure technology. For cloud operator, we are pay attention to the new technology, especially related to the network or the technology itself. For cloud operator, we do not have much control of the edge. I mean, there are a lot of buzzwords in this area about 5G and edge computing and IoT. For the traditional cloud operator, they do not have much resource on the edge. So they are paying very attention to the infrastructure technology changes and trend. The ADD also is a hot discussions we pay attention to. And also another driving force is about internet governance and policy enhancement. It's most related to the privacy and equipped DNS. I think the two forces will work together and have some tension to shape the future DNS technology. And the second one, I would like to say that application level DNS will change largely the diagram of DNS ecosystem because the people in Alibaba already do this for years. So we know how it can achieve, what it can achieve, and how what's the benefit which it has. But my question is that right now it's there are many department-dependent solutions for ADD kind of application, but how to interoperate with different platform, or interoperate with the current ISP. That's the concern or questions I would like to follow. Next slide. Okay, some hopes, and I think the team member of Alibaba DNS see some challenges, like the threat of security, like DOS attack, and other kind of security threats. So we need more information, some collaboration together to fight against the security threat. And we also foresee that the future scenarios with complicated, mixed scenario that multiple clouds may cooperate. So there need some interoperable technologies to provide some choice for the customer. And we also think that it's a challenge for the technology itself and the governance itself and the tensions between them. Just like Alibaba do, I think one value Alibaba do for a long time is to build trust between buyer and sellers, build trust on the infrastructure itself. So we're hoping that we can achieve more collaborations to build trust and consensus in the community and share the best practice and information with you. And we also want to support some open source and standardizations if we think that's the right direction. Okay, as an ending, I would like to say that I heard that many people say DNS is old stuff, but we still think it's just the beginning. So let's build a stable and secure infrastructure together. Thank you.
Okay, are there any questions for Davey?
Hey, David, this is Jian from Facebook. I saw your slides that you managed to get the propagation within 10 seconds. Are you able to give a little bit detail on how you do that? Do you actually shard your servers for different zones, something like that?
Okay, I bring one of my colleagues who are senior engineer on that. Please, Mar Yung. Can you give him a
Why don't you stand at the mic?
Yeah.
So your question is how to spread the data to the whole world.
Within 10 seconds.
Closer 10 seconds. Okay.
Stand in front of the mic.
Okay. Because I think we defined our self protocol to distribute the data to the whole world, and we use a lot of service, a lot of resources to do it. So and we have a stable and fast network in the whole Alibaba infrastructure. So we can keep the latency between every node, and we can push the data and use our specified protocol to do it. So we can keep the latency stable and keep it spread quickly. So I think, yeah, it's a lot of detailed things. I think maybe. Yeah.
Okay, the mic line is closed after Shane.
Hi, this is Victor Duchovny. I do DNSSEC surveys, some folks know. And in China, I see very little adoption at the moment. I found 390 signed domains in China out of 3 million. Is there any prospect of that changing? I'm curious whether there's any sort of signs of greater adoption coming, or is it still likely to not be happening for a while?
From authoritative part, we see momentum that that's why we are going to launch our version of DNSSEC in Alibaba DS authoritative. We see momentum that the customers are asking that properties. I cannot come out with the exact timeline or exact number. Maybe when we launch this services, then I will have more detailed information. Okay.
Okay.
Okay, and for the audience, Victor, could you state your name and affiliation, please?
I did.
Oh, did you? Okay, sorry.
I'm Victor Duchovny, and in the DNS world, it's a hobby, so the affiliation. But I work at 2 Sigma. They don't do much in DNS, but yes.
Petr Špaček, CZNIC. I just want to say thank you for coming to the DNS community. That's a huge change when we compare that with the situation before the previous Flag Day. So I'm very happy that you are here and you look forward to cooperation. Thank you very much.
Thank you. Hi, Shane.
Hi, Davey. I'm Shane Kerr from NS1. Good to see you again.
Yeah, yes.
I had a question about the HTTPS DNS SDK. Is that primarily for provisioning, or does it provide something like DOE, DNS over HTTPS?
You're asking about the HTTP DNS. It's already a product provided for the mobile developer. What's the exact question?
Oh, so it's for mobile developers?
Yeah.
And it's for DNS lookups, right?
Yeah.
Oh, okay.
Yeah.
Okay, thank you.
Yeah. They already have the product introduction in the website. Yeah, if you are interested, I can forward some material. Yeah.
Hi, Davey.
Okay, Case.
I have a comment from the Jabber room
Okay.
to relay from Peter van Dijk at Power DNS. Peter is saying, hello, Davey. It's Peter van Dijk at Power DNS. I apologize for jumping on you at this with an issue, but I just noticed that a few hours ago, the name servers for one of your zones are causing trouble for resolvers that do both QNAME minimization and RFC 8020. With several resolver operators, both public and private, looking to roll out such features, it would be good if you could have a look. Conveniently, one of the officers of RFC 8020 is sitting right next to you. And he's pasted the relevant messages and domain names into the Jabber room for the workshop.
Okay.
So I don't think that's a question. I think it's just a comment.
Yeah, we can collect some barks or some findings. Yeah.
Okay, thanks. Sounds like you and Peter should follow that up offline.
Yeah.
Okay.
You can. Anyone can send mail to me. I have mail in my first page. Yeah. Any questions, follow up, or findings, or bark, or complaint about services, send mail to me.
Okay.
Okay. Thank you. Thank you very much.
Okay, our next speaker is Matt Plosel from DigitalOcean. And this is Matt's first ever OARC, so let's give him also a warm welcome. Thank you. And he's going to be talking about the DNS Transparency Project.
Hey, everybody. Just want to start off, thank you everyone for being here rather than home, family, Halloween time. I really appreciate it. My name is Matt Plusell. I work at DigitalOcean, but I'm actually here on behalf of DNS Transparency. There's about 5 or so individuals that make up DNS Transparency project. So what we're trying to do is similar to SSL transparency, where if we have the data, we can make better informed decisions. We became aware of this late last year with the situation I'm going into, where we didn't have the data, and it presented some issues. So right now, if you want to see DNS records, you can pull them. You can have all kinds of tooling that reaches out and checks your records. This can be your A records, or let's say for your NS servers or higher up on the chain, those records. The problem is you end up having a lot of different individuals involved, a lot of different systems involved. And there's really some challenges to ensure the data that's being served is correct. And that doesn't mean that the system is broken at all. I'm just saying that there can be additional things that we can add to help us out when there are problems and make us more aware. So around late last year, around late last year, we identified a little bit of problem where the current architecture is obviously registrants, registrars working together to the registries and the TLD name servers to push out records. And all of this happens behind the scenes, as you guys know. But if a record is changed, that can be through a compromised account, that can be a compromise of an organization, or an infrastructure. I really don't know if my records were changed. So what we can do is monitor, right? This is what we do today. We keep polling, check my records. But for a lot of us, if you have 1 million records or 100,000 records or run a TLD, this becomes not realistic, especially with the window in time that issue occurred late last year. The issue that I'm referencing is sea turtle and DNS espionage. If I could raise a hand, how many people are familiar with that incident? Okay, cool. I'm at the correct audience. I'm more familiar with that incident than I want to be, but it highlighted some issues where if my polling and monitoring tools are looking at my records, the problem is some of the really good organizations, they're pulling these on a 60-minute or 1-minute intervals. Some of the organizations we interacted with had 3 or 4 monitoring tools. They did not catch a small window of time where their NS records for TLDs were pointed somewhere else. And a lot of this has to do with the NS records for TLDs were pointed, but were serving the correct content to the majority of the audience. So this presents a little bit of an issue where if I'm polling all the time, you're actually missing the live updates. So what we're trying to do is change it from a pull-based model to a push-based. So interacting with individuals here, TLD operators, registry, registrars, getting that data is very helpful. So our primary role is just to be the clearinghouse for collecting, interacting with the different organizations, and getting it available to then give to recipients. I'll get to that in a second. So we kind of broke it out into a couple different phases. I'm open to work with all the different phases if you're available to chat about it. But the idea is to interact with the different operators. And unlike SSL transparency, I can't really say I'm a vendor and I'm going to say your root CA can't go in my browser unless you meet these criteria. That doesn't work with DNS. We're a global infrastructure. We don't push rules onto other countries and operators. That's a slow process that likely everyone in this room is very familiar with. So what we're trying to do is a voluntary interaction. So the idea is to get some information and kind of push it upstream. So just like the SSL transparency, the idea is to get the data to a pool so that whoever is going to use that pool can then make the tools, just like certificate transparency model. It's been a community-based situation, a couple of key players, but our role is just to collect the data and facilitate it. And that's a lot of work, but I want to separate the different tasks. So right now, let's say you're running a TLD. We can pull data from either being a slave part of those DNS servers, or you can facilitate it to us any way that's easy. But the idea of this is to get this data and then provide it either from targeted and filtered outputs. So let's say I'm .gov, I just want to know the .gov changes. Maybe I want to alert every time my NS changes or anyone upstream of my, let's say, .gov or my domain changes. So I don't know if everyone's familiar with VeriSign Transitive Trust, but it makes for a really good graph of my domain depends on 99 different things that are outside my control. And when you kind of see it visually, it makes some sense of why we need this data. A lot of TLDs, their NS records are other TLDs. And so it ends up being this very complicated situation. But if we have all the data, now we can provide everyone the ability to see and receive the data and use it as they desire. So the real-time perspective here really matters. The window in time for the incident last year and earlier this year and other incidents, the window in time in which I can change a record, point it somewhere, make an SSL cert is very small. It can be very effective very, very quickly. So the risk and threat is actually occurring, and we're trying to get as real-time data to people as possible to facilitate what they need to do to respond. So protobuf for just the raw feeds. If anyone else has other inputs, I'm all ears. It's really understanding what the needs are for both receiving data and then facilitating it out. One of the concerns was if we're facilitating data, so bob.com, we don't want to notify bob.com that their domain just got pointed somewhere else and their NS records and their MX records and everything are now pointing to an undesired location. We probably don't want to send them an email using that domain, so that also supports the idea of separating out the responsibility. So if we're just collecting the data, there's a likely other partners or organizations that are better suited to reach out to these organizations through relationships or a service or whatever people want to do. I don't think sending emails really makes sense. And we did a little bit of a test with that. I don't think a TLD operator wants to know every time an NS record changes. So we're currently in the state where anytime you're making a legal document, obviously we want an organization for that to fall under. So we're finding a home mostly for the nonprofit situation. So people-centered internet and InventSurf is helping out with that. And that's going pretty well right now. We'd definitely love any additional input or collaboration or support. What we're working on right now is just proof of concept of how to receive the data, how much data that is. Obviously, the GTLDs we're starting with first, are kind of focusing first. It makes for an easier test case rather than a small CCTLD. So depending on which role you guys fall under, registries, we'd like to review how to interact with you guys. I think based off everyone's roles, things are very different. So we've learned a lot along the way. I'd also really like to get some feedback of organizations that can receive the data, what you guys want to do with it. Obviously, there's rules and restrictions that we want to keep in mind, right? We don't want this data to be misused. We don't want it to be causing additional problems. But the idea is understanding what people's use cases are for it. And if people are able to put in effort to build out something of a transparency, notification service, or a live feed to an intelligence feed that a lot of organizations already have, definitely all ears there. We always have to have the slide, but because we're nonprofit, because we're neutral, donations and money is always nice. The understanding of, obviously, we want to stay neutral. So there's the contact information, and I'll be in the corner if anyone wants to chat about things. So, appreciate it.
Okay, thank you, Matt. So I think we have time for one question, maybe.
Hi, thank you for your presentation. This is Martin from SIDN. So if I understand it correctly, you want to get the data from the TLD registries directly?
Yeah.
Okay, so I work for a CCTLD, a European CCTLD, and I know from experience that most CCTLDs don't share their zone data. So I think I like the idea, but I think it's going to take a very, very long time for European CCTLDs to be able to share this data, if ever. And might even, because of the GDPR rules in Europe, it might even become impossible to do so.
Yeah, we've had a couple chats about, obviously, the privacy concerns, or there are some sensitive TLDs that understanding when changes occur, we need to understand the bigger picture. Yeah, we'll have to kind of figure out where we can go with that. There've been some discussions of, is a public record a privacy issue or not? And if we get it live, is that changing things or not? So I like to step back from the legal or compliance expertise, even though I work in security. I'd really like to have chats on that to see.
This can be a very deep rabbit hole.
Yeah.
Thank you.
Hello, my name is Tom. I work at Cloudflare. I have a question kind of similar to privacy, but on a different angle. The intention is that this record would be publicly visible by anybody?
So
generally,
yeah. So my stance is, as much as I want it transparent, I want it transparent to an audience in which are not the misbehaving or potential misbehaving audience. So if the idea of closed door versus open door, public is public.
I guess the idea is
maybe somewhere.
The producer of the data could consume it, and potentially other people, you're saying, but not necessarily any random person on there. I ask because, from experience, people sell data sets of domains. My question was going to be, can you enumerate domains in a TLD with this? I guess the answer is yes.
Yeah, I think right now the idea of aiming towards the intelligence and security and operator community, that's really things work better and easier if it's just that audience. But how to weigh the equities is definitely a conversation.
Okay, thank you, Matt. So let's give him show our appreciation to Matt. All right, a couple of quick announcements. We have a coffee break now. It's from 10:30 to 11 a.m. I'm told by Keith that they're wheeling in the coffee into the back of the room, coffee, etc. So you should stay in the room if you want that. I just want to apologize quickly for the technical issues we were having with the clicker, but I'm told Matt Poundset and our crack team of techies are going to fix the problem over the break. And lastly, another quick reminder about lightning talk. So we're accepting submissions until the morning break tomorrow. We've had a couple submitted already, but we have plenty of room for more. Okay, thank you.